From yesterday's lecture, what did we learn that an ionic bond was?
It is where valence electrons are taken and given.
Okay, so this is a give and take of valence electrons. Speaking of give and take, who usually is doing the giving? Is it metals or nonmetals that give? Okay, so we probably want to write down that metals give valence electrons. Correct? And we should write down that as far as the take part goes, it is nonmetals that take electrons. So metals give electrons and nonmetals take the electrons. Now if you are giving up electrons, what does that mean is going to happen to the metal? Is the metal likely to become positive or negative?
Positive.
Very good. So metals are bound to become cations, whereas nonmetals are bound to become anions. Now a cation, is that positive or is that negative?
Positive.
Okay, so a positive cation, and anions themselves are negative. So one thing that you have to be confident doing is jotting down basically the number of valence electrons and charges of stuff. So I'm going to give you a chart to write down real quick, kind of as a practice. With your buddy next to you, does everyone have a buddy next to them? Juan, do you have a buddy? Very good. I'm going to get you to work on this chart with your buddy that is next to you. If you need a buddy, I can be a friend, which would be great. I don't mind. And we're going to fill out this practice chart to give us just a little bit of extra practice. So again, right here, you're looking at the answers that I have for the document. Go ahead and check your work real quick. Remember, metals are for sure on the left side of the periodic table. Nonmetals are on the right side. Valence electrons, got to be able to count those guys. Cool? We good? Okay. Now at the bottom, one thing I'm going to get you to do real quick is I want you to draw out the Lewis structures of maybe this guy, and this guy real quick. Let's draw out the Lewis structures. You remember what that is, right? We'd write down Cl. Okay, so what we have here is the Lewis structures. Your dots don't have to be the same orientation, but you need to have 7 dots around chlorine, 6 around sulfur, and 2 around strontium. Are we cool with that? It doesn't really matter, no. The orientation is irrelevant. Are we cool with this? Okay. Now you know for sure that metals are positive, nonmetals are negative, and the metals are giving their electrons to the nonmetals, correct? So I'm going to show you now how to do a Lewis structure, not of just a single element, but of an ionic compound. So this is a Lewis structure of an ionic compound. So let's do this real quick. Probably the most simple ionic compound in the world is going to be sodium chloride, which is table salt. So you could write out Na and Cl. And let's go ahead and put in all the number of electrons that they each have. So how many valence electrons does sodium Na have? Okay, so let's do that one single dot right there. And how about chlorine? How many valence electrons does it have? 7? Okay. So something like this, correct? 1 valence electron for sodium and 7 for chlorine. Okay. Now, the sodium is going to do what? Is the sodium going to give or take electrons? Give, because metals always give. And non-metals always gain, correct?
Yeah.
So hopefully you're watching closely. We've drawn the arrow showing the movement of that electron. Correct? So what this produces is this produces the Na. But now what's the charge of Na since it has lost an electron?
Positive.
Very good. By how much? Positive how many?
1.
Because it lost 1 electron. And the Cl has gained how many electrons? Gained how many? 1 from the Na, correct? So now it would be appropriate to draw Cl with the 7 valence electrons. And what's its charge? Minus. Because it has gained 1 electron, correct? And we should draw a bracket around the nonmetal always. Maybe up at the top we're writing ourselves a little note about Lewis structures of ionic compounds, and you might want to just add just a little bit of something up at the top. The anion always has brackets around it. Cool? Brackets around the anion. Let me show you something else. I'll give you another example. Let's look at Li and F. How many valence electrons does Li have? 1. And F has how many? 7, because it's in that 7th column. Who's going to lose the 1 electron? Lithium will, and fluorine will gain it, correct? So which way should our arrow go, from lithium to fluorine or fluorine to lithium? Always draw from the metal to the nonmetal. We had said before that metals lose and nonmetals gain, and you're seeing that for the second time here. I'm going to draw my arrow, and I'm going to let you take about 30 seconds and write out the products real quick. What are we going to be producing here? Draw out the Lewis structure of the product. We're going to have Li, correct? What's the charge of Li going to be? Because it has lost an electron. What's the charge of F going to be? Because it has gained an electron. How many electrons should it have around it now? Yeah, because it has gained that 1 electron. Minus 1, and always put the anion in brackets. Remember, the anion is the negatively charged ion. Yes, sir? I think you might want to put minus 1 for now. Now I'm going to show you a different example. Mg with S. How many valence electrons does magnesium have? How do you know it has 2? It's an alkaline metal. Got 2 valence electrons. Sulfur has 6, right? Who's going to be losing the electrons today, magnesium or sulfur? And who's it going to lose it to? Okay, so we draw the arrows from magnesium to sulfur. Notice that we're drawing 2 arrows this time though, because magnesium is going to give up 2 electrons. In the end, what are we going to have? Mg, and what's magnesium's charge going to be?
Plus 2.
Because it's losing how many electrons?
3.
What's the charge of sulfur going to be? Very good. And it's going to have how many electrons around it?
8, 8, 8.
Cool? Let me show you a couple more, and then I'll let you go. Al and Cl. However, there's going to be 3 Cls. I'll let you take a second, and why don't you put down the number of electrons that everything has. The aluminum has 3 valence electrons because it's in the 3rd column. The chlorines each have 7 because they're in the 7th column, correct? Okay. Do you see why you would need 3 Cls now?
Yeah.
How many electrons can each Cl take?
1.
Each Cl can take 1 electron. How many electrons does aluminum have to give?
3.
So you would need 3 Cls. Not 2, not 1, not 4, but you need exactly 3 Cls. So we can draw the arrows.